So in this video we're going to continue looking at difference quotients. This time we're going to look at the other type of distance quotient, which honestly is usually going to be more work algebraically. It may seem like it's simpler, but it's actually usually more complicated. Again, they will tell you in the problem which of the two difference quotients they want you to use. Here we're dealing with the function f of x equals -4 over x squared. And we want to compute the difference quotient for f of x minus f of a over x minus a. So first we write down our formula, and now we plug in what we know. F of x would be -4 over x squared minus f of a will be -4 over a squared, and then that's all over x minus a. Now at this point we have a little bit of a mess to simplify. There's a few ways that you can approach this. One option is you could take the two things in the top and say, hey, those are fractions. So I need to get a common denominator and I can put them all together. But this thing where we have fractions inside of fractions has a name. It's called a complex fraction. And one of the common ways to simplify a complex fraction isn't to put the fractions together by adding them. Rather, it's to get rid of the fractions by multiplying both the top and bottom, both the numerator and denominator of the big fraction by the common denominator for the little fractions. In other words, we're going to multiply both top and bottom by x squared a squared, which would be the common denominator for those two little fractions. And we're going to multiply both the top and bottom. And we're going to simplify. So we're going to distribute through. When we take the x squared a squared times that first fraction, the x squareds are going to cancel out. And so we'll just get -4 a squared. We now have two minus signs, which will make that a plus sign. And again, when we take x squared a squared times this second fraction, the a squareds are going to cancel out. And we'll be left with just 4x squared. And then in the bottom, I'm not going to multiply through. I'm just going to leave that in its factored form. X squared a squared times the quantity x minus a. Because just like in the problem that we did previously with the f of x plus h form, where that denominator h canceled out, in a difference quotient, that denominator usually is going to cancel out. So at some point we need that x minus a that started in the bottom to cancel out. And we're going to see how that's going to happen as we work through the problem. So first things first, in the numerator I can factor out a 4. I'm also going to rewrite that with the x squared first, so it's a little bit clearer what we're dealing with there in the numerator. I could have written it 4 times minus a squared plus x squared, but you might not have seen it as a difference of squares as clearly, because that's what we're going to do now, is that x squared minus a squared can be factored. And so we do that. And again, the denominator just tags along as it is, not changing anything about it. Now, finally, we can get rid of that x minus a factor in both top and bottom. It will cancel out, and we have our final answer, 4x plus a over x squared a squared. And again, what that tells us is the slope of the secant line. So if we know two values for x, like x equals 1 and x equals 3, we could find the slope of the secant line between those two x values. And that's what a difference quotient does, and this is how we compute it. And again, the key idea is at some point that denominator is going to cancel out. It should cancel out as we're simplifying that starting denominator. Now, it's not saying we might not have other stuff in the denominator later, but that starting denominator needs to cancel out generally with these difference quotients. Okay, so that's difference quotients. We're going to move on to our final topic in the next video, which is talking and reviewing a little bit about symmetry.